a little weird. So yes, I will attempt to record this. Okay. It says it's recording, so hopefully it works. Okay, Michaela, did you have another question? Your hand's still up, or is that it? Okay, Michaela, I'm going to put your hand down just because I assume that's all. All right, guys, so you should have a piece of notebook paper out right now for your warm-up, though. Everyone needs that. Your warm-up, remember on the top of your warm-up paper, you should put something that says like chemistry warm-up. You should put that it's week 14. You need to put day 1 for today, and then under day 1, you're going to put your work for today. You have 4.50 grams of Ag, which is silver, and you need to turn it into moles. I'll give you a couple minutes to work on that, and then I'm going to call on a couple of you guys to ask what you got. Okay, guys, we're gonna go over this warm-up. Okay, let me erase the whiteboard. Oops. Okay, I just drew a smiley face. If you can see my smiley face, I'm gonna write next to it. Okay, so we started out with 4.50 grams of Ag. And we want to know how many moles there are. Okay, so what we're going to do, I hope everyone's listening, paying attention, tuned in. Hopefully you have a calculator. Hopefully you have a periodic table. Hopefully you have a pencil. You got your warm-up. All right. Take what you're given and put it over 1. We're going to convert these grams to moles. So because you have grams of Ag on top, you need to have grams of Ag on bottom so that they'll cancel. And we're going to take those grams and turn them into moles of Ag. So wherever we see the word mole, we're going to put a 1. And then where we see G for grams, we're going to go to the periodic table and find the molar mass. So Angeli, are you there?
Yes, I'm here.
What'd you get for the molar mass of Ag?
I got 107.87.
Perfect. 107.87. Good. Okay. So that is all we need to do because we're just going to moles, so it's just one step. Anvi, can you go ahead and put this in your calculator and tell us what you got?
Yes, I got 0.04.
Okay, wait, what else? So, give me unrounded first.
Okay, 0.0417168.
That's good. Perfect. Okay, so guys, we need 3 sig figs because our original number here has 3 sig figs. Remember, you go by the original number given to you in the problem. You don't go by your molar mass. So because our original number has 3 sig figs, we need to round this to 3 sig figs, but these leading zeros don't count as significant. Okay, so if we were to round this to 3 significant figures, it would be 0.0417 moles of Ag. That's 3 sig figs, okay? Because those zeros in the front are not significant. And that is how you do it. Oh, I don't know why the MOL is not showing up for you guys. Maybe it is for some of you. But that's an O and an L. There we go. And there's an AG here. That's weird. Okay, that's what it should look like. I'm not sure why it wasn't showing up on the other screen. Okay. Okay, questions on the warm-up. Okay, so today we're going to go through the worksheet that I gave you the link to the PDF in the chat. Again, you can print it out if you'd like. If you don't want to print it out, just have a piece of paper out because we're about to go through it. Okay. So you guys have a quiz. Let me share my desktop with you so you can see what I can see. Let's take a look at what we've got going on this week. If you look at the Dragon post, this is everything we're going to be doing this week. This is week 14. Okay, so this is everything we're doing this week. This is super, super helpful. All right. Here is what we're doing each week. I don't know if we'll have time to start the study guide today. I'll give you class time to work on it tomorrow. I think it'll post later tonight if you want to start working on it, or right here, you can click this link if you want to start working on it today. Okay. Tomorrow we're going to have a quiz. Okay. The quiz is going to cover some nomenclature, meaning some formula writing, as well as the type of things we're going to be going over today. Okay. So it's going to be going over basically pages 18 through 22 in your binder, as well as writing names and formulas. Okay. On day 3, I'm going to give you time to finish the study guide. There are no videos this week. Here are some links to PDFs you might want to print out. Here are the assignments we're going to be doing this week. Here's the warm-up for each day. We're going to have student hours today from 4:15 to 5:15, and you're going to have a test next week. So this PDF tells us everything we're doing this week. So if you have no excuse saying, oh, I didn't know that was due, or oh, I didn't know where to find that, because everything is right here. Okay, everything is next to this big dragon. Okay, this PDF. Okay, today when we're done, if you follow along today and you write everything correctly and you turn it in right here, you'll get 100 in the gradebook. So today is a day for you guys to review all the stuff that we learned last week or 2 weeks ago, as well as prepare for your quiz, as well as to hopefully get an easy 100 in the gradebook. Here's a CJ slide for today. Okay. All right, so let's come over here. Oh, that's not. There we go. This is the worksheet we're going to go over. Again, if you don't have it printed out, no big deal. You should have a piece of notebook paper. On your notebook paper, you need to write, you need to write chemistry calculations. You need to put your name at the top. Okay, write your name at the top. Let's jump right in. So let's come over here. Number 1, so let's label it number 1. Number 1 says write the empirical formula for each of the following compounds. So number 1A, we have C2O2H4. Okay, so if I'm writing the empirical formula, that means I need to reduce the subscripts. So Ariana, what is something I can divide all of these numbers by?
2.
Perfect, 2. So I'm going to divide them all by 2. When I divide 2 by 2, I get 1. I get 1. I get 2. So let's write it as COH2. Okay? Perfect. Okay, number B, letter B. So this is C4O. Now remember, it's like there's a 1 there, H10. I can't really divide any of these. Like there's not anything I can divide all these by because of this 1 here. So this cannot be reduced. Because it cannot be reduced, we are going to come over here and just rewrite it. Okay, that means its empirical formula is its molecular formula. And we're just going to leave it like that, okay? Okay. This one, C. I've got C4O2H8. Aisha, are you there? What can I divide all these by? Aisha?
I'm sorry, can you repeat the question?
Yes. So I've got a 4, a 2, and an 8 here. What number goes into all of these? What can I divide them all by?
2.
Perfect. I can divide them all by 2. And if I divide them by 2, divided by 2, I get a 2. Divided by 2, I get a 1. Divided by 2, I get a 4. So it'll be C2O H4. Perfect. Thank you. Okay, Bo. Are you there, Bo?
Yeah, I'm here.
Okay, Bo. So look at D. You got C5H10. What could we reduce that to?
Oh, CH2.
Yeah, so we could divide them both. What did you divide them by?
5.
Yeah, divide by 5, and you can get C1H2 or just CH2. Perfect. Excellent. Thank you, Bo. And Colin. Are you there, Colin?
Yes.
All right, Colin. What could you reduce P6S6 to?
Well, because they both have 6 in them, it could reduce to PS for P1S1.
Perfect. Well done. So divide them both by 6. It's just going to be P1S1 or just PS. Perfect. Yay. All right, good job, guys. So that one's pretty simple. It's just reducing the subscripts. That's how you would do those sorts of problems. Okay, number 2. Now we're going to get into calculations. So again, you need a periodic table, you need a calculator. So if you don't have those things, go grab them and come back. Okay, so number 2 says, what is the empirical formula? What is the empirical formula? And it gives you some percent composition data. So it tells you how much hydrogen, how much nitrogen, and so what we're going to do, sorry, I zoomed in a lot. We have, come over here. We have hydrogen, nitrogen, and oxygen. So we know we're trying to find an empirical formula. So our answer is going to be H something, N something, O something. That is supposed to be a square. I'm not sure why there's a delay on that. All right. So we're gonna figure out what those subscripts are for each of those numbers. So what we have to do, if you remember, we did this on page 22 of your notes. If you start with percents, your first step is to take those percent signs and change them to grams. Okay, and once you've done that, we're going to take those grams and turn them into moles. And that is our first step. Take those grams and turn them into moles. So let's start with hydrogen, and then we'll do nitrogen, and then we'll do oxygen. So let's start with hydrogen right here. We have 1.58 grams of hydrogen. Let's take it and put it over 1. And we're going to change it into moles. So the way we do that is like this, because we want our grams to cancel. And remember, G for grams reminds us to go to the periodic table. So when we go to the periodic table, Diego, are you there, Diego? Diego, are you there? All right, let's go to Zeke. Are you there, Zeke?
Yes.
All right, what is the molar mass of hydrogen on the periodic table?
It's 1.008.
Perfect. All right, Zeke. And if I put 1.008 there, let's go ahead and divide 1.58 divided by 1.008. Can you do that, Zeke, and tell us what you get?
I got 1.56.
Perfect. 1.5, well, technically 1.57 if we round, right?
Yeah.
Perfect. Okay, thank you. Okay, so that is, we took those grams of hydrogen, we turned them into moles. So good. Let's do the same thing with nitrogen, and then we'll do the same thing with oxygen. So let's do nitrogen next. So nitrogen, the problem says we have 22.22 grams of nitrogen. So 22.22 grams over 1. Okay, same thing. We're going to take those grams and turn them into moles. Same way. You guys will be really good at turning grams into moles at the end of this. Okay, Gio, are you there?
Yeah.
All right, what's the molar mass of nitrogen?
Find it. So it's like 14.01.
Perfect. 14.0. All right, and since you're here, can you go ahead and divide 22.22 divided by 14.01 and tell us what you get?
One 1.586009993.
Perfect. So let's do 1.586, just to keep it the same sig figs as 22.22. Thank you. Okay, so we turned our nitrogen grams into moles. Let's do the same thing with oxygen. So oxygen, the problem gives us 76.19 grams. Put that over 1. Okay, and we're going to turn that into moles as well, which we're super good at now. We're doing it 1,000 times in a row. So let's see, Ian, are you there, Ian? Ian? All right, let's go to Jacob. Are you there, Jacob?
Yeah.
All right, Jacob, what's the molar mass of oxygen on the periodic table?
Wait. 13.6.
Wait, are you sure you're looking at oxygen? On the periodic table? Do you have a periodic table, Jacob? Should I come back to you? Oops. All right, Jacob, I'm going to come back to you. Okay, guys, the periodic sorry, the molar mass of oxygen is 16. So when we divide those two numbers, we should get 4.76 moles. Okay, all right. So now that we have this, we've taken all of our grams and we've turned them into moles. Now that we have moles in all of these, we can look at which one of these is the smallest. So, John, are you there, John?
Yes.
Okay, John, out of these three numbers, these three mole amounts, which one's the smallest?
1.57.
Perfect. So do you remember what we have to do next with that smallest one?
You divide all of the numbers by the smallest one.
Perfect. Thank you, John. Okay, so we're going to divide all of them by the smallest one. So we're going to divide all of them by 1.57. So divide by 1.57. Wow, that 5 does not look like 5. That looks like an 8. 1.57. Sorry about that, guys. And divide by 1.57. Okay, so we're going to divide all those by 1.57. When we divide 1.57 by itself, we get 1. When we do 1.586 divided by 1.57, it's going to be something very, very close to 1. It's like 1.01 something. And this last one, when we divide it, we should get something very, very, very close to 3. Okay, now these are our subscripts. Okay, so you should always get whole numbers at this step, or if you remember from our notes last week or 2 weeks ago, on page 22, sometimes you can get something like 1.5 or 2.5. If that is the case, then you would have to double your subscripts, but you should either get a whole number or something 0.5. So our subscripts are going to be H1 and 105. Oh, 3, sorry. That wasn't right. H1 and 103. So if I was to write this nice and pretty over here, it would be HNO3 would be the answer. Okay. All right. So that's how you do a problem like that. You will definitely see a problem like that on your quiz on day 2, and you will definitely see a problem like that on your test next week, and you will definitely see a problem like that on your pre-comps. Okay, so I'm just trying to prepare you for all the things that are coming your way. All right, now I was grading some of your homeworks from before break, and some of you guys were skipping steps on these problems. Like you would convert to moles, but then you would forget to divide by the smallest or something. So just don't skip any steps. Okay, make sure that you're following all the steps that are in your notes. Okay, let's do number 3 together. So number 3 says how many formula units in 99.0 grams of chromium 3 phosphate? So it says hint, write the formula first. So if we're going to write the formula first, we need to write chromium 3 phosphate. So I'll give you guys a heads up. you guys are going to have on day 2. The first half of the quiz is just going to be nomenclature, meaning writing names and formulas. So you need to be, prepared for that. So chromium 3 phosphate. So chromium is Cr, and the +3, the Roman numeral 3 tells us it's a +3. Did that work? That didn't work. Okay, hold on. Aha. My stylus broke, so now I'm using my finger. Don't know if it'll be prettier or uglier. Okay, so phosphate is PO4. Phosphate, the fact that it ends in 8 tells you, hey, this is a polyatomic ion. And polyatomic ions you can find on the back of your page, I think it's page 12 of your notes. That's where your polyatomic ions are. Okay, so because this is a 3 and this is a 3, they're going to cancel out. And you're going to get CrPO4 as your formula. Okay? Okay, so that's your formula. So now it says how many formula units in 99.0 grams of this? Okay, so we're taking grams, we're turning them into formula units. Since the word mole is not in this problem, if the word mole is not in the problem and it's a conversion problem like this, then you know it's going to have a couple steps. So if we're starting off, I'm going to zoom in, scooch over. So if we're starting off with 99.0 grams, and we don't see the word mole in the problem, that means it's going to be 2 steps. Because we're going to have to convert to moles, and then we can convert to formula units, okay? So because I have grams on top here, I know I'm going to need grams on bottom here. And then my first step, like I just said, is to take those grams and turn them into moles. So I'm going to put moles up here. Notice I haven't even filled in any numbers yet. I like to fill my units before my numbers. And because I have moles up here, I need to have moles down here, so it'll cancel. And then I'm ultimately looking for formula units. So that's what's going to go here, and I'll just abbreviate it. Okay, so now, let's see. Joseph Casas, are you there?
Yes.
Perfect. What number, Joseph, should we put next to the word mole on both of those moles? What number needs to go there?
1.
1. Perfect. Thank you. And Sebastiano, or is it Sebastian? I always forget.
It's
Are you
Sebastian.
good?
Yeah.
Sebastian. Ah, dang it. Someday I'll get it right. Okay. What do we put next to formula units?
6.022 times 10 to the 23rd.
Perfect. So 6.022 times 10 to the 23rd. So wherever we see formula units, or remember, a formula unit is just the same thing as a molecule, but for an ionic compound. It's a weird word. But whenever we see formula units or molecules or atoms, we use Avogadro's number, 6.022 times 10 to the 23rd, okay? Cool. So now, G for grams tells us to go to the periodic table. So you guys all need to go to the periodic table and calculate the molar mass of this CrPO4, okay? I'm going to give you about a minute to work on that. So everybody get out your calculator and your periodic table and calculate the molar mass of this compound here. And then I'm going to call in one of you at random to tell me what you've got. So be ready for me to call on you. Okay, let's see. Misty, are you there, Misty? Misty, are you there?
She typed it out.
Hello, perfect. Gracias. Okay, let's see. That is what I got as well, 146.97. Thank you. Okay, so let me write that in. 146.97. Okay, so let's cancel our grams, cancel our moles. And that's the setup. So I'll give you guys a moment to go ahead and get out your calculators and put that in your calculator to calculate. You guys need to practice using your calculators, especially with scientific notation. So go ahead and do that. I'll give you a minute to do that, and then I'll call on one of you at random to tell me what you got. All right, Vicky, are you there, Vicky? All right, Tanisha, are you there?
I'm here.
Tanisha, were you able to calculate that and get an answer?
Yeah.
What'd you get?
I got 4.05 times 10 to the 23rd.
Good. Okay, so we got 4. Did you get like 4.05646, something like that?
Yes.
Okay, so I'm gonna write the unrounded one right here. Sorry, there's like a delay. Okay, so that is the unrounded answer, but I need to round to 3 sig figs, which you did round to 3 sig figs, but you need to be careful because this 6 will bump that 5 up to a 6. Okay, remember if it's 5 or above, it bumps it up. So it's going to be 4.06 times 10 to the 23rd. And that actually brings up a good point. So you guys are going to have, and this will be formula units of CrPO4. You guys are going to have a quiz next class and a test next week. These quizzes and tests are free response. They are not multiple choice. So that means you can't just guess your way through it. So that means sig figs are going to matter. I'm going to tell you how to round your sig figs. If you make a mistake on sig figs, you won't get the whole problem wrong, but you will get a couple points off. So just make sure that you're careful about that and the way you're rounding it, okay? Excellent. Thank you so much. Okay. All right, does anybody have questions? I'm going to pause here for a second. The whole point of me doing this live is so you guys can ask questions if you need to ask any, or if you're wondering where anything came from. Does anybody have questions? No? Okay. Let's do number 4 then. Number 4 says the empirical formula of a compound of boron and hydrogen is BH3. Its molar mass is 27.7. Determine the molecular formula. Okay, it wants us to tell it the molecular formula. So BH3 is the empirical formula. It wants to know what the molecular formula is. So it's going to be something H something. It's going to be basically the non-reduced version of BH3, okay? It gives you a molar mass here. That's the molecular molar mass. That's the molar mass of this molecular formula. So what we need to do is we need to divide this by the molecular mass of our empirical formula. So let's figure out the molar mass of our empirical formula. So BH3. Calculate the molar mass of that by looking at our periodic table. Okay, boron is 10.81 on the periodic table. And hydrogen is 1.008. However, there are 3 hydrogens, so we need to multiply that times 3, and that will give us 3.024. So go ahead and add that up, guys. I'll give you a moment to add that up. Add up your boron and your 3 hydrogens. And Sydney, are you there?
Yes, I'm here.
Were you able to add that up?
Yeah, I got 13.834.
Perfect. That's what I got. Sorry. Okay, so 13.834. So that's the molar mass of the empirical formula. And we're going to do our, so let me change colors just to try to keep it kind of organized here. So we're going to do our 27.7 divided by our 13.834. And you should get a whole number. So go ahead and do that in your calculator. Shashwath, when you do that, what did you get in your calculator?
I got 2.
Okay, so something really close to 2, right?
Yeah.
Perfect. So, Sarah, are you there?
Yeah, I'm here.
Okay, Sarah, what are we going to do with that 2? What does that 2 tell us? Like, what are we going to do with it?
We multiply it by each one, so you'll end up with B2H6.
Perfect. Thank you. So they'll end up with B2H6. So we basically multiplied these subscripts up here by 2, and then this was our answer. So we got the molecular formula, the non-reduced version of that formula. Okay. All right, any questions so far? All right, let's do the last one. This is probably the last one we'll have time for today. So it says calculate the molecular formula. So what we have to do in this problem is we have to calculate the empirical formula like we did number 2, and then do all the steps that we did number 4 to calculate the molecular formula. So this one is kind of a big problem. That's why I gave you a lot of space to do it. And the reason I'm giving you this problem is not because I want you to be miserable, it's because I want you to be prepared because you could see something like this on pre-comps, okay? So first step, if you remember, is to take those percent signs and turn them into grams. Okay, so let's take our grams and turn them into moles. So we have 85.7 grams of carbon. And we're going to make space down here to do the same thing with our hydrogen, our 14.3 grams of hydrogen. So we're going to turn these into moles. So let's start with our carbon. So I'm going to put it over 1. And then I'm going to basically just divide by the molar mass. So G for grams tells me to go to the periodic table. The molar mass of carbon on the periodic table is 12.01. And when I do this in my calculator, I do 85.7 divided by 12.01. Ryan, are you there?
Yes, I'm here.
Ryan, what do you get when you divide those two?
I got 1. Wait, 7.14.
7.14, perfect, thank you. So that is our moles. Okay, and now let's do the same thing with our hydrogen. So we're going to put 1 mole on top because we're taking our grams and we're turning them into moles. So the molar mass of hydrogen is 1.008. So we're going to divide those two. Misty, are you there? Ravi, are you there? Ravi.
Yeah.
Hey, what did you get when you divided these two numbers? 14 point divided by 1.008.
$14.1867.
14.1. Oh, okay, perfect. And Misty, I just saw your thing pop up. Perfect. 14 point. Let's do 14.2. Okay. Super. So now we've converted everything to moles. Our next step is to divide by the smallest number of moles. So we're going to divide both of these by 7.14 because that's the smaller one, right? So divide both of them by 7.14 because that's the smaller one. And I apologize for the crazy, messy handwriting. It's kind of hard to write on this. So when you divide 7.14 by itself, you get 1. Divide these two, you're going to get something really close to 2. So our empirical formula is, let me scooch over here. Our empirical formula is C1H2. However, we need to know the molecular formula. So the molar mass of this, in the interest of time, I'm just going to tell you what I got for molar mass. The molar mass of this is 14.026. So we're going to do our 70 grams divided by our 14.026. So I'll come over here and I'll do 70 divided by 14.026. And when I divide those two, I'm going to get something very, very, very close to 5. So what am I going to do with that 5? I'm going to multiply my subscripts by 5. So instead of C1H2, my answer is now going to be C5H10. That's supposed to be a 5. Sorry, it's messy. C5H10. Okay. So a lot of kids will do these steps. They'll get to the step where they get C1H2 and then they'll stop. You don't want to stop there because that's your empirical formula. You then got to go one step further, use that 70 that was given to you in the problem to solve for the molecular formula. Okay, the rest of the problems on this worksheet, guys, are for you to practice if you want to do them. However, I will not be grading them. I will not grade you on them, okay? So if you just did 1 through 5, you are good to go. Take a picture of it, submit it under your assignment that says chemistry calculations, and hopefully everyone got 100 for today. If you want to practice these, that's not a bad idea. Go ahead and practice them. In student hours, you can come ask for the answers and I can help you through them if you want, because questions like this may be on your quiz tomorrow. We just don't have time to go over them in class. Okay, so I don't want to burden you with them if you have a lot going on, okay? So go ahead and take a picture of numbers 1 through 5, submit them, and once you did that, you are good to go. Michaela, do you have a question?
So it's just 1 through 5 that we take a picture of?
Yep, you only need to take a picture of 1 through 5. If you want to do the rest just for fun, you can do them, but you don't have to.
Okay, thank you.
Yep. All right, guys, I'm going to hang up this call.